All right. Okay. Hello there. Welcome back, everyone. There we go. Let me just start my little timer here. All right. Cool. Great. Awesome. Welcome back, everyone. So, it's obviously going to be Monday by the time I record this, but that doesn't really matter. Let's talk about something else. What I want to talk about with you is I want to make another video about structs in general and how we use them, because I feel like in the previous one I wasn't very informative. I think I did miss a couple of things there. I remember that I missed a couple of things and it wasn't that great. You know, don't really like missing things, obviously, so I am going to kind of make an insert, I guess. This video is more like an insert that, like, to the previous one to kind of like point you in the right direction, because I feel like I didn't talk about certain things that I think I should have. So this is like a bonus video. Let's just take this as like a bonus, like a short bonus video, and I'm just gonna quickly talk about structs. So let's go. Let's go. So I'm just gonna go here and just say bonus right here. So here, what we want to do, what I want to talk about is allocation. So we will allocate structs using the malloc. So let's talk about that a bit more. And then here I also want to talk about functions. Initializing, so just initializing structs. So let's say returning a struct from a function like this. And I want to talk about just like structs in general. So let's do this. So normally you would see a lot of structs around, either when you use Microsoft or whatever. They're very common, and I'm just going to build on what we know from the last video. So let's make the same struct like we did last time, okay? So let's declare struct person, and here let's actually do let's actually properly explain what's going on here, because I feel like I kind of messed up last time. So what's happening here is that you actually kind of want to always remember. So I'm just gonna say here, so pro tip number 1, right? That would be, so pro tip number 1 is like always, so always declare fields in structs from largest to smallest. What do I mean by that? Well, that's easy. So in a struct, always make sure to allocate to create your fields from the largest data type to the smallest data type, right? So for example, a person has a name, an age, and let's say an initial, right? So let's actually see how the size of this struct changes. So let's see. So I'm just gonna print here, make a little printf function really quickly. So size of struct. So struct person. This is how you do. You always make sure to use the struct keyword. So this struct now, as it stands, has. Why am I putting it a string? What am I doing? What am I actually doing? So as it stands, it has 0 bytes. So this is 0 bytes now. As you can see, there is 0. So as you can see, this struct is empty, 0 bytes. Now what you need to do is think to yourself like, what is the largest data type I want to hold in my struct? Is it perhaps an integer? Or is it perhaps a string? A const char pointer. Remember that a char pointer is 8 bytes, and int is also 4 bytes, but a double is 8 bytes as well. So we can work with this, right? So let's say that I want to store a typical record of like a string, maybe 2 strings, you know, maybe some like numbers or whatever of a person. So let's store a 1 string and that's name. Let's do. So I want to have a string and that is a name. Let's see now how the our size changes. So remember this right here. So this right here. Oh fuck. So this right here, char pointer is 8 bytes, right? There we go. Char pointer is 8 bytes. Therefore, this struct should now be 8 bytes in size. And we can see that it clearly is. Great. So now what happens? So now I can add another string if I want. Like let's say const char pointer, let's say date, right? Like maybe date of birth. So this is another 8 bytes. So this struct size right here. So this struct is, and then we will say size. So this struct would be, let's say it would be 2 times 8 bytes. 2 times 8, therefore 16 bytes. 16 bytes in size. Let's check it. Let's check if it really is 16 bytes in size. I should be right on this one. Yes, as you can see, it indeed is 16 bytes in size. Maybe I can add another const char pointer, right? Like another string. Maybe you wanna store, I don't know, some just random string, whatever. This would be another 8 bytes. So now this would be 3 times 8, which would be, I have absolutely no idea. Let's bring out the calculator. So that would be 3. Oh fuck. That would be 3 times 8, and that is 24. So this right here should now be 24 bytes. So this right here should now be 24, and as you can see, it indeed is 24. So there's a pattern here, isn't there? So if we are allocating the same data type like this in a struct, our struct, so I'm gonna add this here. So pro tip 2. So if we are allocating same data type, right? Getting the same data type in a struct, so we can basically say that it's number of fields times size of data type. Data type gives you the size of struct. Oh, struct, right? So we can actually say this, can't we? That the size of our struct, if these are identical, is just this multiplied the amount of times you plan to use it. Okay, that's great and all, right? That's awesome. That's all great. Cool. Whatever, right? There is a problem though, because this does not apply when the struct has different data types. So obviously, for example, if you stored only integers in here, obviously it would be the same. So for example, int a, this would be 4 bytes, for example. So this would just be 4 bytes in size now, as you can see. And then when we add b, so when we have 2 integers here, there would be 8 bytes now, as you can see, and it will just continue the same way. So this, instead of being, for example, n amount of fields times 8, it's n amount of fields times 4. And remember, right here at the top, so this first line right here, this very first data type that you put into your struct needs to be the largest one in your struct that you're going to plan to use. And then every subsequent different data type that you change needs to be smaller than this first one in your first line where your struct starts. So let's actually show ourselves. how this works. At least that's the general convention of how we do it. So let's do it. So let's say that if I want a name, so I'm gonna put a const char pointer name first, because I know that this is the largest data type I want to hold in this struct, because then I'm just gonna either hold a string or an integer. Now, what happens here is that we add 8 bytes, right? So we add 8 bytes, or allocate 8 bytes, right? So this adds 8 bytes to the size of our struct. But something weird happens. Because, for example, right now, I wanna, for example, store an integer. But something weird happens here. So this is like 1, right? And now, if I wanna add an integer, for example, int age, right here, we add another 8 bytes. So add 8 bytes, right? So it adds another 8 bytes. Because now we just assume that we're just going to go down from here. So the reason why we add 8 bytes is because all of these need to fit into this. So for example, all of these data types right here that are smaller than your largest data types in terms of size need to fit n amount of times into your large data type here. So if you have 8 bytes, you can either have 8 chars, you can have, for example, 3 shorts, or 2 integers. I think it's 4 shorts, yeah. 4 shorts or 2 ints. Because all of those fit into this one variable. So, for example, this adds another 8 bytes. Right? So, for example, here, this will be 8 bytes in size. Our struct is now 8 bytes. But if I add int, for example, int age, this will, for example, so this will add another 8 bytes. 8 bytes. Okay? Let me show you. So now this should be 16. As you can see, it is indeed 16. And then if we declare another integer, for example, let's just make this clearer. If I put another integer here, let's just say, oh, I don't know, maybe weight. No additional size gets added. And this is important. No additional memory gets allocated for this variable, this field right here. This struct, in fact, will be 16 bytes. As you can see, it indeed is. So even though I've added another field of type integer right here, it still didn't allocate new memory because it allocated 8 bytes. And we can fit 2 ints, 2 integers into one char pointer. So in one string, we can fit 2 ints. So we can just allocate 8 bytes right here, and then we don't have to allocate any additional memory here. Right? And then, if I put another integer, let's say int a, here we would add another 8 bytes. So as you can see, it always adds the amount of memory gets allocated for the variables depending on your largest data type right here. So if the largest data type was 4 and I would have, let's say, shorts, it would add 4 bytes each 2 shorts. So I don't know if that makes sense. I hope it does. So that's the reason why it's so important to keep your largest data type right here at the top and then just add smaller and smaller. So let's see. So I'm going to just type in. So let's say if largest data type is char pointer, which is 8 bytes. So what can fit in a char pointer? So we can fit 2 integers. That equals 8 bytes. We can fit, for example, 4 shorts, right? Short, so we can have short, and short. Short, right? Because we have 2, 4, 6, 8, right? So one char pointer is equivalent to 2 ints, 4 shorts, and 8 chars. So let's see. 1 char pointer is equivalent to 2 ints, 4 shorts, and 8 chars. So without the pointer. So as you can see, 2 ints, 4 plus 4 is 8, 4 shorts, 2, 4, 6, 8. And then 8 chars, because char is 1 byte. So we can fit this amount of stuff. So therefore, so for example, if we have 8 bytes as our max, every second integer, new 8 bytes will be allocated. Every fourth short, more 8 bytes will be allocated. And every 8th char field, 8 bytes will be allocated. So that is how structs work. I didn't mention that in the last video, and I was like, my god, that is so important. So for example, the correct way to store a record of a person would be to declare the name first. For example, if you want to store the birth date, for example, as a string, like this, and then maybe age would be like this, and then maybe weight would be like this, right? So if you want the weight to be an integer, for example, or maybe a double, you will put it up here. So this will be a correct way to declare a struct of this. So we have 8 bytes right here. So let's see what the size of our struct is. So right here we got 8 bytes added. Since this is another string, we simply add 8 bytes added. Right? 8 bytes added, because we don't have any more, we can't borrow any more space from the previous allocations. Now here, remember, if the data type changes, we still add 8 bytes. Right here. And then here, no allocation. Because this happens because we still have like extra 4 bytes available right here, right? So because we still have extra 4 bytes available to us, we don't need to do more memory allocation, because that would be wasteful. So here, instead, so no extra allocation, because we have 4 extra bytes of memory available. Therefore, this int will take these 4 extra bytes that are left over from this previous allocation and will be allocated there. Therefore, if we count this, if I grab my calculator here real quick, so this right here should indeed be, so we have 8 plus 8, right? Plus 8, and that's it. So technically we should have 24 bytes, so it's 8 times 3. So technically the size of this should be 24 if I'm not mistaken. Yeah, 24 as you can see. So it is indeed 24 bytes. So there we go. So now you actually know how to handle. So far, this is as far as I'm gonna go. Obviously, there is a lot more complex like data allocation with like doubles and whatever. But I will go over that in a more of an advanced video later, because I just want to cover the basics of. I just want you to know that this is this thing that exists. So for example, now, so yeah, so this is how we create a struct. You already know that. Mike, obviously use the memset function. Always use the memset function if you are using a struct like this. Always, always, always zero out your structs. This is really important. Otherwise, you're gonna receive some very weird behavior from your program. So this is really important. And obviously now we can start like assigning variables like this. or whatever. But that's actually not the preferred way. I'm gonna teach you how we can actually initialize these with let's say functions. So we can have two types of functions. We can pass in by reference, or we can just simply create a struct with the function. So we can just simply say, so initialize person, and then here we can take in the struct. So we can take in struct person There we go. So we can take in the struct by reference, obviously, and then we can just initialize our fields. So const char pointer name, const char pointer birth date, const int age, and then const int weight. There we go. There we go. So what we do here is we just simply say person, and then name equals name. Person weight equals weight. Person, let's say birth date equals birth date. And then person age equals age. Good. So we have name, weight, birth date, and age. So we have all of them. So this is how we can initialize our struct, for example, using a function, passing by reference. This restrict keyword, if you are questioning what that means, it means that this pointer will not be reassigned in this scope anymore. So that's basically what that means. Let's go and actually now print our stuff. So now we can say init person. We're going to take in Mike by reference. So this is our person. Let's do Mike, 11, 11, 11. And then let's do 21. And then weight is 666. There we go. And now we can actually start printing, for example, the name. So we can do Mike.name. And this will give us Mike, as you can see. So we can do it like this. So this is one of the options, as you can see, of initializing your structs. But we can also return a struct from a function. Now, there's a lot of ways you can do this. I'm going to just teach you the very basics, and then we're going to move up later. Okay, so now we can basically create a form of like a constructor function in a way. So we can say struct person, right? Struct person. And then right here, pointer. And then let's say create person right here. So it returns a struct person pointer, which is important. I'll tell you why later. And then here, we simply just pass in all the values here. So const char pointer. So char pointer name. Const char pointer. Let's say birth date, and const int age, and const int weight. Okay, good. So now we can actually return a struct, right? So we can return a pointer to the memory address of the struct that we've created here. So we can say struct, let's say person, new person. We can do it like this. Then we can say new person dot name equals name. New person dot birth date equals birth date. New person dot age equals age. And then new person dot weight equals weight. So we are returning a pointer because we want to return the memory address. So we want to do return new person. So it's an address of stack memory. I think if we work, it needs to be heap memory. Yeah, I think we need to allocate this on the heap, right? So this can't return. I think we can actually just return a new struct like this, right? Just pass it. Okay, so yeah, I think we can just return the copy. Anyway, there is another way. If you want to return a pointer, here you would use a pointer right here, and you would basically use the malloc function. So struct person pointer malloc like this, and then you would use free on your actual scope. I think for now, I think it's good enough to do it like this. I think it should work. So now we can basically create like a little constructor, quote unquote, function for our little, for our. So it just basically returns a copy of the struct, basically. So let's see. So we can basically say our struct person, let's say Mike, and then we can equate this to create person, and then here we can basically say Mike, and then birth date will be 11/11/11, 21, and 666. So right here, we can basically return a struct like this from a function and create like a little of a constructor function if you want. It's not really a constructor, but we can call it like an initializer function or something like that. We can basically do this. So you can either create a struct like this, like in your field here, and pass it by reference and initialize it like this. I think, honestly, in my opinion, I would rather prefer it to... I would probably prefer doing it this way, but there's a possibility to do it this way as well. So now, if we just say print, let's say s Mike.name, we should be able to see that this prints Mike, if I did things correctly. Yeah, so as you can see, it indeed does print Mike. So we can sort of, you either have two choices. So either you want to create a struct, so either you want to, let's say, create a struct person, so Laura, like here, and then you want to use the init person function and pass in the memory address of your struct, and then initialize it like this. Let's just put some stuff here, and then 21. There we go. So as you can see, you can either do it like this. So we can then we can then print fs, and then here we want to say Laura.name. Or you can do it like this, where you use this constructor function right here to return a struct, and then we can print Mike.name, right? So these are the two ways of doing it. So you either pass the memory address of your struct, you pass in it by reference like this, and you initialize it like that, or you basically use a function to return a new struct from the function and basically assign it to a variable like this. So there you have these two ways, at least for a basic. Honestly, I think I prefer doing it this way, right here, passing the struct by reference. I think that's a more of a C style way of doing it, but I think you can also do it like this too, so it should be fine. So there we go. So that's what I wanted to talk about today with you, pretty much. I think I missed this a little bit in the last video, so that's the reason why. Obviously, always keep in mind that this will be right here, so always keep in mind. So just to recap, I'm going to make you a little summary. So always remember to declare your largest data type you plan to use in your struct first, all the time, every time. It will help you sort of calculate the size of your struct much better, and you're not going to waste memory, which is one of the best parts about this. And then here, you see that then your other largest data types go right after, and then smaller and smaller and smaller and smaller data types. If you want to declare a different data type, it needs to be smaller than it needs to go down. And as we implied here, if your largest data type is a const char pointer, which is 8 bytes, therefore a char pointer of 8 bytes is equivalent to 2 integers, which means you can declare 2 integers after declaring a const char pointer. You can either declare 4 shorts, over here after declaring these const char pointers, or you can declare 8 individual chars after this one without wasting any memory. So to recap again, if you over here, if this is your largest data type, therefore a const char pointer is your largest data type. Therefore, if you then switch to ints, then 8 bytes will be allocated every 2 integers. Every 8 bytes will be allocated every 4 shorts, and every 8 bytes will be allocated every 8 chars, depending on what is your largest data type that you select. If it's integers, then if your largest data type is int in your struct, then you need to only go down from there. So then you should only decrease the sizes if you want to declare different data types. So, for example, you shouldn't be declaring an integer and then a const char pointer and then an integer and then a const char pointer then a short. You shouldn't be doing that. It needs to go from largest to smallest to avoid wasting memory. So there we go. That's all I wanted to summarize essentially in this video. I hope it's helpful to you in any way. And yeah, yeah, I hope it helps. I hope this helped because it's important. And obviously we also talked about the functions here. So you can have 2 ways of creating a struct. If you want to create a nice function to help your people like work with your struct, for example, you can create a function where you pass in the struct by reference, you give the memory address of the struct, and then you write here, you initialize it like this, by reference, or you basically create a function that returns a new struct, and you create a struct in your function, and then initialize it and return it back to your, and you can then assign it like this to a variable. So, there we go. So that is your 2 ways of doing it. So there we go. So we have created a function that initializes the struct, and a function that obviously, and a function that creates the struct. Ideally, I think I did a little mistake. You should be doing this. So let's zero out this struct person. There we go. So we need to zero this out, and we also need to zero out this one as well. There we go. So ideally, this is the way you want to do it. So now this should be like perfect. The perfect way of this should be the way that you should be doing it. So don't forget to zero out your structs, obviously, as you can see. There we go. Now it works super fast and super well, and it's all good. So as you can see, this is exactly how you want to do it. So you can choose either this function or this function. It's up to you. You should probably you obviously make sure to practice with it, and you will get it in no time. So this is it. This is the entire video. I want to make like a little bonus to kind of like make sure that like I cover kind of everything when it comes to like beginners and structs and whatever, and beginners dealing with structs. So yeah, I think this should be it. Yeah, so yeah, I'll probably make like a little piece of notes as well that maybe clear up certain things, but yeah, for now this is it. So I'll probably see you in Python next time. So yeah, this is the end. Thanks for watching. Obviously, it was always appreciated. And yeah, I think you can. I think you should probably go and what was it? Fuck, I don't know. Maybe you should like, I don't know, like and subscribe. Maybe. I don't know about that though. That would probably be like way too like wild. So. Whew, I don't know. It's kind of scary, isn't it? So, yeah. Maybe don't do that. Anyway, I'm gonna go now. Make sure to subscribe and like. That would also always be appreciated. It's always nice. Appreciate the support. It helps out a lot. And I'll see you next time in Python doing some random shit. Probably working on the reverse shell in our malware marathon series. So that was a lot to be excited about. So yeah, see ya.